Hey guys, this is Miss Went, and I want to help you a little bit with the worksheet called Ohm's Law. So this worksheet's all about this equation, current equals voltage divided by resistance. So let's recap what all that stuff is real quick. So here we have a circuit, and you can see the batteries up here. If I increase the voltage, so add more batteries, you can see that as I do that, the current, so the amount of electricity going through the wire, also increases. If I take some batteries away, the current goes down. So voltage and current are related. If one goes up, the other goes down. That's called an inverse relationship. Now, resistance is how hard it is for the electricity to get through the wires and the light bulbs of the circuit. So if we add more resistance, if we make it harder for electricity to go through, so you can see in this red bar down here, we're adding resistance, it's making it hard. The current slows down, we have less current getting through. If we take away those barriers, if we take away the resistance, it's easy for the current to move and our current goes up. All right, so that's what these parts of the equation are talking about. V is voltage, how many batteries? I stands for current, and that's because the letter C is already used for something else in another formula, so they're using the letter I here. And then R is resistance, how hard it is for the electricity to get through. Okay, so that's what the parts of this formula are. You can see we measure current in amps, voltage in volts, and resistance is a unit called ohms, named after the scientist George Ohm that figured all this out. And because we can't use an O for our symbol because it would look like a 0, we have this Greek letter that kind of looks like a circle with a little base at the bottom. This is the symbol for ohms right there. All right, so little recap here of what our symbols are for when we get to some circuit pictures later. So first we have some math problems, and this worksheet is so nice. It's rearranging the formula in 3 different ways for you, depending on what you're looking for. All right, now remember that the letter I is for current. So question 1 here, how much current is in a circuit that includes a 9-volt battery and a bulb with a resistance of 3? So I don't know how much current I have, but I do know that my volts in this problem is 9 volts. And I'm going to divide it by my resistance of 3 ohms. And I'm not going to type the symbol for ohms because that would take a lot of keyboard strokes and I'm really lazy, so I'm not going to do that. But if I take, oh my goodness, we don't want to do that. All right, so if I take 9 divided by 3, serious computer. All right, so I equals 9 volts divided by 3 ohms. My answer is going to be 9 divided by 3 would be 3. And that's my current, and current is measured in a unit called amps. So I do want to make sure that I'm labeling all of my work. So 3 amps is going to be my answer here. All right, so you're going to go through and do these math problems here. If you're not sure what formula to use, remember all 3 are listed here for you. So those I think are going to go pretty easy. The answer is not 3 for all those. I don't know why the computer's doing that. All right, now in the next part here, instead of giving you numbers, they're giving you diagrams. So we have to kind of figure the diagrams out. So I figured this is probably the part you're going to need a little more help with. So first we're asking, what's the total voltage in each circuit? Well, voltage is measured by, we got our batteries here. So this first one, letter A, has a 6 volts of batteries, so 6 volts. And then the second circuit over here, letter B, it looks like it has 2 batteries. So we got more energy there. That's going to be a total of 12 volts. Okay. Now the current, remember we have our formula. Seriously, what are you doing here? Our current, our formula was current equals voltage divided by resistance, right? If you're not sure, like, oh wait, what was it? We can go back. Ah yeah, current voltage divided by resistance. Okay. And again, I don't know why my computer is filling it in everywhere. That is crazy. But it's saying if the light bulb has a resistance of 6, my voltage is 6, so my current would be 6 volts divided by a resistance of 6, and 6 divided by 6 would give me 1 amp of current. And that's for letter A. Now letter B has 2 batteries. So my current here is going to be 12 volts this time. I still have that same resistance in the battery, 6. This time I have 2 amps of current running through. So if I have twice as much batteries, I have twice as much of the current going on. Now, if I change the resistance and the light bulb has a resistance now of 12, I have the same formula. So my current here, I still have a 6-volt battery in that first one, but this time I'm going to divide it by 12 ohms. 6 divided by 12 would be 0.5 or 1/2. It is totally cool to have decimal numbers with this math. That is not a problem. For my second circuit, I've got 12 volts of power. Now the light bulb has a resistance of 12. That 12 divided by 12 is going to give me 1 amp. And guys, I apologize for why the numbers keep changing on the other problems. I have no idea why it's doing that. All right, letter D. Is the bulb brighter in circuit A or B, and why? Okay, well, circuit B has more current. So there's more energy flowing through, so that's going to give us a brighter bulb. B has more current, so B will be brighter. Okay, for number 13, what happens to the current if in a circuit if a 1.5 volt battery is removed and replaced with a 9 volt? Well, if I take 9 divided by 1.5, that's going to give me 4. So 9, come on, computer. 9 divided by 1.5 gives me 4. So the 9-volt battery is 4 times stronger than the 1.5 volt battery. So the current would be 4 times larger with that bigger battery. And that makes sense. A bigger battery is going to give you a bigger amount of energy flowing through those wires. Okay, now number 14, I'm going to leave that for you, but think about if one goes up, does the other go up? If one goes down, does the other one go up? Are they moving the same or opposite? So we looked at that, this guy here, right? So if the resistance goes up, what happens to the current? And if the resistance goes down, what happens to the current? So is it easier for the current to go through, or is it harder for the current to go through? That's what number 14 is talking about. And then the same thing with 15. If the voltage goes up, so if you add more batteries, what happens to the current? Okay, so that's what relationship means. If one thing goes up, what happens to the other thing? All right, 16, if you want to increase the current, there are some things you could do with adding or taking away batteries, changing the wires. Do you want thicker or thinner wires? Okay, so those are some things you can think about to answer 16. Same thing with 17. If you want to decrease the current, what can you do about the batteries? What can you do about the wires to make less current flow through? Okay, now number 18, you have a big box here. And you are going to draw 4 different circuits. Okay, so there's going to be 4 different circuits in the box, and if you need more space, you know, add a page or whatever, that's fine. And you know the symbols for circuits, so your job is to try to draw a circuit that gives you 1 amp of current. Okay? So you don't have to use all these materials, but these are the materials you have. Okay? So you have up to 4 1.5 batteries, and you've got some bulbs with some different resistance. So what combination of things would give you a 1 amp of current? Draw a picture. What combinations of things would give you 2 amps of current? Okay? Now, I can't draw it on the computer with this pen, so I'm going to go to a different page here. So if I was going to draw a circuit, I'm going to need a battery. So battery is a big line and a little line, and they're going to be connected to my circuit. So there's my battery, and maybe this has 1.5 volts. I have 1 battery. And then maybe I'm going to put 1 light bulb in my circuit. So there's my 1 light bulb right there. Okay, now if this light bulb has, say, 2 ohms of resistance, then this circuit, if I want to figure out the current going through, I would take my voltage, 1.5 volts, and divide it by my resistance, which is 2, and that's going to give me 0.75 amps of current. Now this does not match any of the pictures I'm supposed to draw, so this is not a good answer. I would have to change something. So I can add batteries, I can use a different light bulb or add another light bulb, okay? So this picture doesn't work, but it gives you an idea of what you're doing, okay? So if I wanted to draw 2 batteries, short, long, that would be a circuit with 2 batteries like that. So that would have 3 volts because 1.5 plus another 1.5 would be 3, okay? And then I could add however many light bulbs over here I would like. So your job is to try to draw some pictures. So you're going to need 4 pictures total, 1 for each of those. And there is more than one right answer. Okay, so if your answer and your friend's answers don't match, you both still could be correct. All right, so hopefully this was helpful to help you get done with this sheet. I didn't answer everything, but you've got some hints. Okay, everything kind of goes with this formula here. And then remember, when you're drawing your pictures, we got kind of the symbols up here if you need them as well. Have a great day, guys. Message me if you have any questions.